Hey guys, this video is a continuation from the last lesson that we had. We pretty much pick up with our corresponding angle converse theorem and we move on from there. Alright, so for the first one, we've got converse of the alternate interior angle theorem. What that's going to tell us is if we have two lines in a transversal and a pair of alternate interior angles that are congruent, then the two lines are going to be parallel. So we're back to just having two lines. We don't know that they're parallel yet. So we've got two lines and a transversal. And if we're also able to show with our two lines and a transversal that our alternate interior angles are congruent, then we can say that the two lines are parallel. So we'd have to come up with some kind of a statement that said angle 3 is congruent to angle 6, or we would have to say angle 4 is congruent to angle 5. If we were able to show one of those two things, then we could say for the statement that would follow that, line A is parallel to line M. We can also do that with our alternate exterior angle theorem. We can do the converse of it. So the converse of the alternate exterior angle theorem, if you have two lines in a transversal and a pair of alternate exterior angles that are congruent, then the two lines are parallel. So first thing we have to have is we have to have two lines and we have to have a transversal. So there's our transversal. And if within the information, the problem that they give us, we can say that the alternate exterior angles, so look in exterior, if we're able to say that those are going to be congruent, then we can say for sure that the two lines are parallel. So we would have to show that angle 1 is congruent to angle 8, or we would need to show angle 2 is congruent to angle 7. And if we're able to show one of those things in a statement, then for the next statement, we can say line A is going to be parallel to line M. Looking at the next one, we have our converse consecutive interior angle theorem. And remember that instead of consecutive, they can use the word same side. It just depends on who writes the problem that you're solving as to whether which one you use, consecutive or same side. Either way, if you have two lines in a transversal and a pair of consecutive interior angles that are supplementary, notice we're still following that consecutive interior angle rule, then the two lines are going to be parallel. So two lines, one line, two lines, and a transversal. And we can show that the consecutive interior angles, and we only need to show one angle pair for these. We don't have to show that they both work, because if one works, automatically the other one's going to work. So if we're able to show that angle 3 plus angle 5 is equal to 180 degrees, or if we're able to show that angle 4 plus angle 6 equals 180 degrees, and this is a big or, then we're able to say that A is going to be parallel to line M. Last one, it's our converse of the consecutive exterior angle theorem, and this one tells us if we have two lines in a transversal and a pair of consecutive exterior angles that are supplementary, then the two lines are going to be parallel. So two lines, one line, two lines, and a transversal. There's our transversal. And we have a pair of consecutive exterior angles, and we can show that they are supplementary. So we can go with those two, or we could go with those two. We only need to show one pair. But if we can show angle 1 plus angle 7 is equal to 180 degrees, or show that angle 2 plus angle 6 equals 180 degrees. Then for the next statement in the proof, we would be able to say that A is going to be parallel to M. And the reasoning we would put beside the A parallel to M would be the converse of the consecutive exterior angle theorem, or converse of the same side exterior angle theorem, just depending on whatever it does. All right, so don't forget to keep using this whole big list that I gave you in the last lesson. All of these are considered fair game. Don't forget, when you're using these without converse, that means they have to tell you that the things are parallel in order to be able to use these. So using parallel lines, you're going to be showing that things are congruent or supplementary. But if you're going to use the converse, and the converse can either go before the postulate or theorem, or it can go out here in front. It just depends on the preference of whoever's making the problem. But with these, you're going to start by having to show things are congruent or supplementary, and then at the end up with things that are parallel. So if you're ending up at the end with things that are parallel, that's going to automatically be converse. So keep this handy while you're working these proofs out, and it'll help you out. It'll give you a list of things to be thinking about. Alrighty, first example that I have for you. Notice there's more blanks, so we're going to be getting more and more blanks as we go through this lesson. Looking at this one, they tell us that angle RST is congruent to angle PQT, and that line RS is parallel to line QT. They want us to complete the proof to show that angle RST is congruent to angle QRS. So this is going to be our given, because that's where they tell us to start, and this is going to be our proof, because that's where they want us to end up. So I'm going to start by marking the things in my picture, because they didn't show this information that they gave us. It's not shown in the picture, so I want to put it in there. That way whenever I look, it kind of gives me a frame of reference for what I already have to work with, and I'm not trying to recreate something that's already there. So they tell us that angle RST, that one right there, is congruent to angle PQT. And with this, there doesn't have to be a relationship with any of the angle pair vocabulary that we've been working with. They can tell us things like that as part of our given, and those types of things help us out a lot. The next thing they tell us that RS is parallel to QT. And notice they say that they're lines, and in the pictures, they give you segments. If you need to, extend these segments out so that you have lines to make it easier to see that they're parallel lines. If you don't need to, you're fine. But sometimes it helps people see that you really do have parallel lines. Okay. So if that's what they give me to work with, we've got to somehow get an angle in there for those to be related. So I either need to relate those two angles, or I'm going to need to relate those two angles. So let's see where this takes us. So they start off by telling us the angle RST is congruent to angle PQT. That's our given. So I'm going to label it as given. The next thing they tell us that line RS is parallel to line QT. Also information they gave us. So I'm going to write it as given. So looking at the next one, they tell us that QRS is congruent to PQT. And we have to come up with a reason of why that's okay to say that. So QRS, this one right here, is congruent to PQT. Well, how are those two angles related? Let's see. Here's a parallel line. So there's a line, and there's a transversal. So those are going to be corresponding angles. And the rule that tells us that they're congruent is the corresponding angle postulate. Alrighty, so then looking at what they did next, they tell us that angle RST is congruent to angle QRS. So looking from step 3 to step 4, I want to see what's similar. Well, there's a QRS there. There's a QRS there. So instead of an angle PQT, they wrote an angle RST. So we want to check up here in our proof and see if there was anywhere that told us that it was okay for them to rewrite angle PQT as angle RST. So if you look back up here to step 1, right there they told us that it was okay to do that. So instead of a PQT, they wrote an RST. So instead of this, they wrote that. That's going to be substitution. Looking at the next example, they tell us that GH is parallel to line FI and that angle FIJ is congruent to angle IFJ. They want us to complete the proof that angle G is going to be congruent to angle GHJ. So this is the information they give us to work with. That's our given, and this is our proof. So this is where we're starting, and this is where we want to end up. So again, I'm going to make sure this information ends up in the picture. So line GH, is that one, is going to be parallel to line FI. That one right there. They also tell us that angle FIJ, so this one right there, is going to be congruent to angle IFJ. Well, if I'm looking, these are our parallel lines. So that means that this one right here, this line right there, it can be a transversal, and this line right here can be a transversal. And there's no direct angle relationships between those two. Those aren't corresponding angles, or they're not consecutive interior angles, because these two lines are intersecting. So we can't use the same side or the consecutive interior angles. So we're going to have to figure out a way to state a relationship between those two. Well, if we're going to state a relationship between those two and we're using HF as a transversal, they're going to have to say something about angle F and angle H, because those would make those two alternate interior. Oh, and they could do the same thing there too. Okay, so I'm going to keep an eye out for the alternate interior angle theorem while I'm working this out. So line GH parallel to FI, that's our given. Angle FIJ congruent to angle IFJ, also given. So next they tell us that angle IFJ, so this angle right here, is congruent to angle GHJ, that one right there. So if I'm using these two parallel lines and I'm using HF as a transversal, there's those alternate interior angles I was thinking that they were going to use. So in order to be able to say that they're congruent, that's going to be our alternate interior angle, and it's the theorem part that has them be congruent.